Today we will talk about supports in structures. We will explain what is a support and what is a support reaction, and how we can identify the different types of supports. And we will show why do we use supports in a structure and how do we calculate support reactions. In 2D statics, a free point can experience three types of motion. We call them 3 degrees of freedom, which are a translation in the horizontal x direction, a translation in the vertical y direction, and a rotation. If motion is prevented in all 3 degrees of freedom, the point will be completely stationary and will not move or rotate. To prevent the movement of the point in one direction, the x direction for example, a reaction must be developed at the point in that direction to resist the force that is trying to move the point. In our case, because we are restricting the motion in the x direction, a reaction will be developed in the x direction. The point will still be able to move in the y direction and will be free to rotate. This condition, in which one translation is prevented, causes a roller support to be created. The roller support will be in the x direction because motion is restricted in the x direction. If the motion is restricted in the y direction, a reaction force will develop in the y direction. Because the x translation and the rotation are kept free, a roller support will be created, and it will be in the y direction. In fact, a roller support can take any direction. The direction of the support is the direction in which the motion is prevented, and it will also be the direction of the single reaction developed in the roller support. If we prevented the motion in the x and y directions, but allowed the point to rotate, in this case, two reaction forces will develop at the point in the x and y directions. This condition causes a hinged support to be created at the point. When translation is prevented at a point in the x and y direction, the point will not be able to translate in any direction. Therefore, if a hinged support is rotated by an angle, the point condition will not change. It will still be prevented from translating in all directions, including the x and y directions. Therefore, we can still represent the support reactions to be in the x and y directions, irrespective of the orientation of the hinged support. If we prevent the x and y translations, as well as the rotation of the point, then two reaction forces will develop in the x and y directions to prevent the translations, and a reaction moment will develop to prevent the rotation. This will cause a fixed support to be created. In summary, the main types of supports are as follows. The roller support, which prevents the point to move in only one direction. The point is allowed to move in the perpendicular direction and is allowed to rotate. The roller support will have one reaction force in the direction in which the translation is prevented. The hinged support, which restricts the point to move in two perpendicular directions, typically x and y, but the point is allowed to rotate. The hinged support will have two reactions in two perpendicular directions, typically x and y. The fixed support, which restricts the motion in all 3 degrees of freedom, the fixed support will have 3 reactions, 2 reaction forces in the x and y directions, and 1 reaction moment. Another support type that is less common than the first 3 types is the fixed roller. This support restricts the point from rotation and translation in one direction. The point is allowed to move in the perpendicular direction. The fixed roller will have 1 reaction force in the direction where motion is restricted, and 1 reaction moment. Why do we need supports in a structure? Consider the following beam. If the beam is left in the air without any supports, it will start to fall freely and is clearly unstable. To prevent the beam from falling, we can put a hinged support at the left end. This will hold the left end of the beam in place but the beam will continue to rotate around that point and will continue to fall. If we then added an extra support at the right end, the beam will stop from falling and will become stable. Supports are needed to maintain stability of structures, but we need to add enough supports to attain this goal. How do we calculate support reactions? We can do that by using equilibrium equations. This will ensure that the value of the reactions will be enough to resist the acting forces and prevent the structure from moving. For more information about how to calculate support reactions, watch the lectures on support reactions, which includes detailed method and examples.